Let's go ahead and go over your lab real quick. This begins our construction of binary trees. We've started in class. I think we've actually implemented the put function for you.
Okay.
So,
And we figured out add.
and you figured out, well, that's put.
Well, a copy.
Okay, you thought about copy, so you're going to have to implement that. We talked about that a little. But what do we need to implement? We have empty constructor, copy, put, in order string, lowest common ancestor. Ooh, we'll have to talk about that. And the destructor, or here I call it the deconstructor.
Low ancestor.
Lowest common ancestor.
That's what he said. Does that mean the lowest number they have in common? Where did it come from?
Ooh, not quite. All right, anyways, we'll get to that.
Yeah, I need to know.
I put some helper functions for you in here if you wanted to, but you can get to those in a moment. You have an empty tree. That should be easy. Set mroot equal to null. Okay. Then the copy tree, we actually talked about that a little, where you're going to need to traverse and add the elements in what order? Pre, in, or post?
We go pre.
Pre. Yep. Pre in order. Put is going to add a value. Do not do any balancing. Balance. In other words, just do it the way we just did it in class, where you just find the correct location it needs to go.
What is balancing?
So a balanced binary tree. So this is not balanced.
Nope.
A balanced binary tree is basically a tree where it's all the levels are filled out except for the last one.
Oh,
okay.
So that's not sorted.
No, this is still sorted.
It's not balanced.
It's not. This is sorted. This
No,
is a
but
binary search
balanced.
tree, but
What
that
is
this is not balanced.
Going on.
So
Yeah.
Yeah, there's no other sides.
But a balance.
that's
what-
balanced, and then you could do this as well.
Yeah, but in order to like make this one balanced.
That's still balanced, but if I added a node right here, it would no longer be balanced.
Because it's on a different route.
It's on. You could put a node here. You got a space here, and you got a space here, right?
Okay.
So balance is where each level is filled out except for the last.
So in order to make this one balanced, it wouldn't be sorted.
Yeah, no.
Or
You
would
could do it.
Just add a whole bunch of like.
Here, hold on. I'll go and convert this to a balanced one for you real quick. Let's see, what do we got? We've got a 30, we've got a 27, so we really need to shift this way first. So we need to first rotate the 62 and the 27, so it's 27 goes down here, 62 up here, 32 up here. Oh, that's all you gotta do. All right, great, and it's balanced.
Is that not sorted?
It's still sorted.
Even with the extra, like 45. Like.
So now we're going to rotate, move the 27 in this spot, put the 62 up here, and have, whoa, hold on, I forgot there's an item right here. So we need to actually, what we really need to do is flip this. We need to put the 27 here, 32 up here, and then the 45 in this location. So the 32 goes here, the 27 is going to go here, the 62 goes here, and then the 45 goes right here. Now it's balanced.
Why?
Because each level is filled out to capacity except for the last.
Oh.
First, level 0 has 1,
Okay.
2 the 1. Level 1 has 2, 2 the first. Then 4. This one would have 8. Next would have 16, 32, 64. Then you have to fill them all out. Except for the last level, of course, is allowed not to have anything, not to be completely filled out, because you may not have that many elements.
So if 45 had something, it would be balanced.
Yeah, if you put a 53 right here, then it's no longer balanced. You'd have to, what you'd probably have to do is move the 53 up here and the 62 over here, and then it would be balanced again.
Okay.
Okay?
Don't do that.
So don't do any balancing. As you can see, balancing is actually can be a little tricky.
Icky.
It's actually not exactly straightforward, although there are some simple, well, I'll say some implementations are simpler than others. I'll put it that way. But don't do this. Just add it where it needs to go once I put it in there, because I'll be testing your binary tree to make sure it's in a certain order. So don't reorder the nodes or don't balance. Okay? Just put them in like we just did. Get height returns the height of the binary tree. In order string is going to return a string representation of the binary tree in order. So you're going to
Wait, how do you find the height? Would that just be counting the?
you can do it recursively. So your height is 1, 2, 3, 4, 5. you'd start at 1, 2, 3. Oh. Max is still 3. 3. Max is 3. Max is 3. Now you have 1, 2. Oh, 4 is bigger. 5. Okay, 5. Max of this is still 5. Max, 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 out. You can do it recursively.
So have like a counter variable?
Yeah, counter variable, or have your recursive function return an integer representing the max down that length, and then pass your function of max and a current height value.
So you could like
In other words, set up the recursion, and then think about what you should pass along. There's different ways to do it, actually.
Yeah.
Okay? So just think of your recursion and how you'd want to pass it along. Very easy recursive function. Well, I shouldn't say that. Once the recursive function is not a long one, you just have to sit down and think about how you type it up. All right, and oh man,
String order, hey, looks familiar.
this does not look good.
Oh no.
You should add a space.
Do I not have the code? I don't think I have your code. I don't have your code. All right, so I will copy over the code right after class, but first let's assignments source 4.text. We need to get a better picture of this. Can y'all see that from back there? All right. So return the lowest common ancestor of two values. The LCA is the most immediate parent of both values. Notice that if the value is of itself, then it's just that number. So let me give you some examples. So here's the binary tree, binary search tree. You got 4, and then 2 and 8 to the left, and the 2 you got a 1 and 3, and the 8 have a 6 and a 10 as a children. So the lowest common ancestor of the 1 and the 3 is of course the 2. The lowest common ancestor of the 1 and 2 is the 2 because it's also the ancestor of 1, so you're just going to return itself. Okay? Lowest common ancestor of 1 and 6 is 4 because 1, 6, you have to go all the way up to the 4 before you can go and get the 1.
So would you like search through?
So what about 6 and 10? That would be 4? Because you said
6 and 10 would be the 8 because it's the lowest. All the way down, you want to go as far down to the bottom as possible. You can do this iteratively, but again, if you do it recursively, it's not that bad. This is the tricky one for the lab.
Okay. So that's
And then make sure you free up the memory. We didn't talk about freeing up the memory, but how do you think you would do it?
everything to
Delete
one.
everything.
Right, what traversal would you probably use? Pre, in order, or post?
Pre?
So you delete it once you get to the node?
No, post.
You want to delete it when you visited everything after the node, so you want to do post order.
And would you
So
set
you
it
can
to
do that
null?
recursively too, right?
Yeah, why not?
Would you set it to null?
You could. Yeah, but
Could
just
you
make sure you set the root to null when you're done is really the big thing, right?
Okay.
Otherwise, just start all over again.
So
Well, bad things might happen.
Infinite loop. It's just like, oh man, it sucks.
if you're
Yeah.
not setting to null,
It works. Forever.
Well, I mean, all you're doing, if you're doing it post order here, guys, I mean, you go boom, 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 can't go, get rid of it, go to the right, can't go, get rid of, can't do anything, get rid of, boom, 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 can't go, get rid of, win everywhere, get rid of, can't go here, get rid of, can't go, win everywhere, get rid of, win everywhere, get rid of, and then set root equal to null and you're done.
so if so how would you determine if it was time to set root to null? Would it
When you're
be-
done with the whole recursive function, you probably have a recursive delete function, make it private, and you pass it root, and it would delete everything, hopefully including root, and then when you're done with it, just set root to null. Okay?
So you need to delete everything or set everything to null, right?
Right.
You use the delete keyword?
Yes, of course. You want to delete, once you get back from a node, delete that node. Right?
So just
So that's what I
delete
meant by.
the So just delete the node instead of setting it to null. You can just
Yeah, delete rover.
think
I need some coffee, desperately. Can I talk to you about the preference?
Sure, one moment. Hold on, let's finish up the lab.
Yeah, I'm done.
All right, now guys,
A lot of brain power.
we're getting close to the end.
Oh, no.
The due date is unfortunately the same day as your final, as your midterm. I keep saying final.
Well,
Yeah.
it's
Yeah.
due March
Stop
3rd.
scaring people.
So, wait.
March 2nd is the
There's
Thursday.
Congratulations.
The day after
Day.
first day of the test. Thank you.
So it's the day after the test. I highly recommend you at least study this, because the binary trees, or at least what we've studied today,
Who
will
needs to study?
on the exam.
Okay.
Any other questions?
Not having one.
You need to what? This
I
this
haven't
class.
studied none of the last
This class made like questions life choices.
Yeah.
I already decided I'm
This
gonna
class
Yeah,
keeps me
guys,
awake.
just trust guys. This is just, it's the coming of age class. You got to get through it. You got to get through this. It's a lot of work,
We
but
can do it.
but you all can do it. Okay, you've gotten to this point. You all can do it. You can all do it. That's not
We
the problem.
haven't dropped yet.
Right. Y'all all can do it. Trust me,
Hey, if I'm
guys. I
paying
know
for
you
this
all
class,
can.
Ain't no way I'm dropping it.
Yeah.
I'll fail it, but I'm gonna stick through to the end.
That's the truth. That's the truth about doing it.
I mean,
You're just
if I'm
and you
paying,
won't have to
if I'm
worry
paying
about it.
for it, I'm gonna get all the information I can.
Right.
Plus it's-
Trust me. You just gotta stick through it. We just gotta. A lot of these
Yeah,
pains.
me too.
I'll take a
We just have to get a
69.9.
Yeah,
I
does
see
it
this
round up in
class.
here?
Then you round down, you're like, oh man.
Yeah, just
Well, but you need this class for other classes too.
Yeah.
Right.
Yeah, so you have
Does it round up?
For me, this is my last semester programming.
yeah. You gotta get through this. This is where you become real
You-
programmers.
sorry.
But yeah, this is where your programming maturity reaches to a good level.
Oh.
What's
I'm
that?
also taking
Let's do
scripting,
the
so
bathroom.
Yeah.
it's my last semester.
Bachelor of Science.
All you guys are.
Yes,
Wait,
of
so you graduated this?
CS.
I still have to take like prereqs. Like
What's that?
gen
The
eds.
BS.
So I still have
Yes,
another
it's
year.
the
I'll be
BS
around.
of CS.
I thought you meant like.
Well, remember-
I figured out how you can take
No,
that.
no, no,
course,
no.
so we're gonna actually
Well,
go
I mean, I
on.
love
You
it.
guys
You
have
have
to take
to
operating
first you get the
systems,
BS,
algorithms,
then you have to master the
computer
BS,
architecture.
and
I
then
don't
you
know how
have
to
to
take that.
have it pilot high D, right?
I feel like after this.
Yeah?
Yeah, I feel like
Yeah.
it's like, oh,
After this,
okay.
I'm planning on doing
Sorry.
a master's in cybersecurity.
Just to confuse everyone. All right. Any other questions about the lab?
Can you do it for me?
Can I? Yes.
Yeah.
Will I?
No.
Will it be correct?
I know what I'm doing.
Ooh, that's a good point too. That's a good point.